Okay, students, Assalamu alaikum. This is my lecture number 2 on complex numbers, part of our revision session. This is basically a summary of complex number, simply a basic idea about this concept of complex number, but very comprehensive, fast and comprehensive. And secondly, we'll be discussing right now the loci, the Argand diagram, how to do different sketches, which is the part of P3 syllabus. We have to study mainly three different shapes, three different types of loci in case of complex number. I'm starting this. The first shape is circle. Suppose if I have this example, suppose if I have the example z modulus is 3. That is the distance, the modulus from the origin is 3. There are infinite possible. You know you how to find the modulus. You can find the modulus in this way: x square plus y square under root. So there are infinite possibilities. Someone saying 3 from the origin till here, someone saying this point, someone saying other point, others having a different opinion, different opinion, different opinion. So we have infinite possible positions where distance of that complex number from the center, from the origin is 0, and you get a circle. Hopefully the idea is clear. So the equation of modulus z is equal to 3 is a circle with center O. And I'm sure all of you have done P1 mathematics, the equation of circle in Cartesian form. If I simply write x square plus y square, which is modulus z is equal to 3, squaring both sides, and now you know this familiar equation of circle with center at O and it is 3. So this is the complex equation, or this is the Cartesian equation. So you should learn in this lecture, you should also be learning how to convert equation in the complex number form into Cartesian form. Now student, this is the standard form, z minus z1 modulus is equal to r, and you know we have the circle, but now the center is not the origin, the center is z1, this point. This means distance of this z, the variable point from z1 is constant r. Every point from z1 distance is r. That becomes your center, and this is the known point. This is the known point, fixed point, and that's the variable point, v for variable. This is a variable point. So you should know the definition of this type. Whenever you have the structure, for example, z minus suppose 2 modulus is equal to 5, it means center is 2, it is 5. This way you identify the shape of the loci, the shape of those complex numbers satisfying z minus z1 modulus is equal to r. Clear? And that is your known point with a real part and imaginary part. This is just an example. I'm just removing this. Now a better example, see here. If you have to sketch z minus 5 minus 3 iota, does not mean your center point is minus 5 minus 3. Your first step is always take the negative sign common like this. You see here, I've taken negative common, left with 5 plus 3 iota. So we need to draw a circle with center 5 plus 3 iota and radius 3. An important instruction or advice here, students, whenever you do such sketching, the loci diagram, always use ruler and compass, pair of compass is important. Ruler and scale and pair of compasses. So that you draw a neat and better diagram. You see here the important thing, this point having the y value 3, the imaginary value is 3, radius also 3. So that should touch the x-axis. X-axis becomes the tangent, or I should replace this by real axis, a better option to write here real axis. If you're not doing the scale diagram, you may find it difficult to make a tangent here. That's why I always recommend my students to use compass, pair of compass and ruler whenever you are doing the loci. So that should be a neat and clear diagram. Is this clear? Second thing you should learn in this lecture, how to convert these shapes into Cartesian form. For example, I have the equation z minus 5 minus 3 iota modulus equal to 3 like this. Z is a variable number. I can rewrite this as x plus iota y. So I make grouping of real part x minus 5. Please observe this. Imaginary part y minus 3. Now this is under modulus. So how can you find the modulus? Square of real and the square of imaginary. X minus 5 square, x minus 3 square, and when you remove root, you have squaring other side also, and this way you got the equation of a circle. You have done in your P1 syllabus last year, Cartesian form, equation of circle with center 5 and 3 and radius 3. So this way you need to learn, you need to practice how to convert complex equation into Cartesian form, right? More ideas. The second shape in your syllabus for these complex number drawings, z minus z modulus and z minus z2 modulus, meaning distance of this unknown complex number from that known z1 and that known z2 both are equal. This is the meaning of that statement. You should understand. From both the points, we need to draw some shape, some loci, some set of points, distance equal from both the points. How to manage this? That is always the line bisector straight line. My z1 is this point, suppose, other point is this. Again, my advice, use the pair of compass, place the compass here, draw an arc with a radius more than half of the distance, both sides. Place the compass here, draw the arc, and then you can draw the bisector. Any point on this bisector, if you take distance from both z1 and z2 at any point, you find both sides equal, both distances equal, both gaps equal. Suppose if I take this point, distance from z1, distance from z2 equal. Is this clear? The line bisector is the name of this shape. We can label this as a line bisector. So we have a perpendicular bisector of the line segment joining z1 and z2. Note down these definitions also. What are the shapes in different cases? Now, example, if it is asked to sketch a loci or locus of points z modulus equals z minus 6 iota. This means z minus 0. So one of the point is 0, other point is 6 iota, because first of all you have to take this negative sign common. It's very important when you mark these points, you have to take negative sign common, because you are taking the difference, a distance. So when I've taken negative sign common, I left with just 6. Here we have 0. Now we need to find the midpoint. 0 and 6, the midpoint is at 3, and draw a bisector, a perfect line which is horizontal line, and that line representing this equation where distance at any point from O and from 6 equal. At any point from 6 from O equal. Now this next thing, if you want to write the equation of the line from the diagram, it's very much clear. It's simply y is equal to 3. But if you want to show the steps, how to write this line in Cartesian form, please pay attention, be attentive. I can replace this z by in the general form x plus y iota, here also x plus y iota. So this having x plus y iota minus 6 iota. These two are imaginary numbers. I've made a group here. Now take the modulus on both sides, under root x square plus y square, under root x square plus y minus 6 square, root cancel out. If you expand the right side, you have x square plus y square minus 12y plus 36. From that side, x square cancel, y square cancel, and simply y becomes 36. Hopefully the idea is clear. If you need to do this again, pause the video, repeat this part, take your notes, then move forward. Now I'm giving you one more example of simple perpendicular bisector. Again, your first step is to take minus sign common. So you have your reference points are 3, minus sign common, and minus iota. Always take minus sign common like this. Then you have the line bisector of 3 is here, this 3, and minus iota is here. Place compass here, draw an arc on this side, from this on the other side. Then place a compass here, draw an arc from here and here. And then you have drawn the line bisector. This is the sketching. Now if you are looking for the equation in the Cartesian form, the same simple technique, replacing z by x plus y iota in both sides if required in the exam. Otherwise we don't need that. If requirement says only sketch, it's fine. If the requirement says find the equation in Cartesian form, then you do the extra working. Now I have made the group of real part x minus 3, here the imaginary part y plus 1. The modulus means under root real square plus imaginary square, under root real square plus imaginary square. Root cancel out. If you expand both sides with the binomial, ultimately you get this equation with gradient minus 3 and intercept 4. You can show your working, you can expand this yourself and get the same result. So we have done two shapes mainly, circle and the perpendicular bisector. Now the third one in your syllabus. If you have argument of z minus a given number is theta, angle is given to you. For example, z minus nothing means 0. It means you need to make an angle from origin from 0 and that angle is pi by 6. What does this mean? This means you have to make an angle from the origin pi by 6 like this. And the shape of this is not a line, because if you extend the line on the other side, the angle is changed. Please pay attention, angle is changed. If it is pi by 6 here, this is negative 5 pi by 6. So it is not a line. Line is a property that line can be extended both sides. I am going to introduce a new word here, which is the half line. This locus of point known as half line. Or you may use another word, ray. Half line or ray can be extended to one side only one side. Is that clear? In this type of equation, the drawing is not a line but a half line. Half line means a point is fixed, other point can be extended, not to both sides. You cannot extend a half line to both sides. And if you are required to convert into Cartesian form, you know argument pi by 6 means z is x plus y iota, and in the last lecture we have done the definition of argument. Argument of z is tan inverse y over x. So if argument is pi by 6, can I say tan pi by 6 is y over x like here, and tan pi by 6 is 1 over root 3. If you cross multiply, you get x into 1 x over root 3. This is the result. This equation in complex form, this equation in Cartesian form. It's very important that you should know the conversion technique also from complex to Cartesian, because this may be asked in the examination. In the first part, draw the loci. In the second part, write down the equation of that locus of points in the Cartesian form. Another example of this. Again, if you have argument of 3 plus 2, z plus 3 plus 2 iota, your first step in every such drawing, bring negative sign here. So you get minus 3 minus t iota. That becomes your reference point from where you draw the half line. From where you draw the half line, minus 3 minus 2 iota. And your angle from this, draw a false axis. And then you see the angle is 3 pi by 4, 135 degree. And you have a half line. This is the half line. Always take minus sign common. Note down this property. This is not a line, this is a half line. Drawing is done till this step. But if the examiner is asking, it is required to write the equation in Cartesian form, then what we do? We can write this z as x plus y iota, and x plus 3 the real component, y plus 2 the imaginary component. Argument means the angle, so tan 3 pi by 4 is imaginary over real. Imaginary is y plus 2, real is x plus 3. And you should know, or you may use a calculator, tan 3 pi by 4 is negative 1. And you got this result, because if you cross multiply x negative x minus 3, I'm writing here negative x minus 3 is equal to y plus 2. Can I say y equals to negative x minus 5? If you just leave the answer of half line here, you lose marks, because you are saying here, or you are suggesting here, you have drawn a line, and line can be extended to both sides. You have to mention the restricted domain also, that this is only possible when the domain is minus 3 or less, you see, and ultimately y is minus 2 or more. That is the real imaginary part and the real part. You have to mention this condition because of the half line. Again, suggestion, pause the video, note down the example. This is a very important or and comprehensive example to get the idea clear. Both things, that is the drawing part, the locus of points, and Cartesian equation from the given complex equation. Now sometimes you find inequalities in these equations, and whenever you have inequalities you need to show the regions, not a point only, like this. If I am saying z minus 4 minus 2 iota modulus then equal to 2, your first step is to take minus sign common, you get 4 plus 2 iota. Now you have center point, you see 4 plus 2 iota, and the radius is 2. Again, this imaginary part is 2, radius is 2, that should be a tangent, it should touch here, it should be a tangent. This is very important. That's why I again strongly suggest use pair of compass when you draw the circles, and always do scale diagram. Now because of inequality, it means the distance from 4 plus 2 iota is either less than or equal to 2. So you have to shade inside also. It's not only the ring or the circumference, it's the anything inside the circle as the region of the required equation. Please note down this idea. Moving forward, and the example. Here we have z minus 4, minus common, this is suppose 4 here. 6 minus common, 6 is here. Now we need to draw the bisector. The perpendicular bisector, very simple, you have drawn the bisector. But the point here is you have just inequality here, no symbol of equation here. So we have no symbol of equation here. So when we have no symbol of equation here, you see here, you should draw the dotted lines or perforated lines. Don't draw the solid line, otherwise you lose marks, because this is not inclusive. Now the distance of z closer from 4 and far from 6. You see, this shows z minus 4 is less than. Distance between z and 4 is less than distance between z and 6. And at the bisector, distances from both the points are equal. So, but the requirement says we want that region where z are the points closer from 4. So you have to shade that part which contains 4. That's it. Any point here in other region, it's far from 4 and close to 6, not required. But any point in this region close from 4 and far from 6, is close to 4 and far from 6. Another important drawing, the half line. Argument of z minus 2 iota, you should take negative sign common. Your reference will be 2 plus 2 iota. See here. And then you have to draw a false axis here, and then the angle pi by 4. Between pi by 4 and 0, you have to shade inside. This is the angle of pi by 4, angle of 0. You have to shade this region, and that is the first you have drawn the half line, and then you have made the region here, and that region representing the required equation. Hopefully the idea is clear. Now if I combine these three into one diagram, see here, I'm doing it myself. If I combine, I'm not doing the scale diagram, but I want you to pause the video here, make a scale diagram first, and then check my working. Suppose this is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Suppose the first one is 4 plus 2 iota. Real part is 4, imaginary part is 2, somewhere here. And you have drawn a circle. I'm not doing very exact drawing, something like this. You should use the compass. Don't shade now, because you have to shade the region satisfying the three equations or three inequalities. Now 4 and 6, this is 4 here, 6 here. Draw a perpendicular bisector passing through 5. You should shade the inside portion of the circle left of 4, because it's closer to 4, but still we have one more equation left. If I've taken minus common, 2 plus 2 iota, this is height is 2 and this is 2 here. Suppose somewhere here, this is the point where you should draw the angle like this. Now you should shade inside. This is the region, required region. If I change color here, this is the required region satisfying the three. It's inside the circle with radius 2. It's closer to 4. away from 6 and the angle from 2 plus 2 iota between 0 to pi by 4. Like in this case, we have to make a circle with radius 1 and center at 1. Take negative common. And then negative common at minus 1, angle pi by 2 and pi by 12. Between pi by 2 and pi by 12. See the diagram here. First, I've marked this center at 1 and drawn a circle. You see it touching at origin y because it's having one radius. And this point is minus 1. I've taken minus common. And this angle is pi by 2, sorry 12, and this angle is pi by 2. So I've drawn the angle between pi, this whole region showing angle between pi by 12 and pi by 2. We need to mark that region or shade that region, identify that region, satisfying both the inequalities. So inside the circle, but at angle above pi by 12 from negative 1, but less than pi by 2, this is the required region. Please try to get the idea clear. And my last example for this lecture. It is very common in the examination. Examiner is asking the least and maximum value of z modulus by giving another equation. Here you know we will draw a circle because by taking minus sign common, 12 plus 5 iota will give you a circle like this. You have a circle here, 12 plus 5 iota. And the radius is 3. If you are looking for the distance of z, maximum meaning from origin. So this is a good idea to connect this with the center first. And this way you can find the length of this which is root 13. Apply the Pythagoras theorem. 12 square and 5 square, what do you get? Root 13. From till center, from z origin is 13. Clear? Now this point is the closest point. So you need to subtract the radius. Z is the distance to the origin. This is the minimize or maximize in the line which connects the origin to the center. To get the minimum value, you subtract this radius which is 3 and get the minimum value, that is 10. Is that clear? This gap is 10. This gap is 10. No other point closer to this from origin. Every other point is far or having more distance from the origin. Similarly, if you want the maximum distance from O to this point, that is, you need to add the radius in the value of 13 like this. You got the idea? So whatever, if I make a general rule, just make the length of OC, C for center, and add the radius for maximum value, and C for center, subtract the radius for minimum value. Note down the example. We'll discuss few more examples from the past papers. In these videos, I'm just giving you a quick basic idea about the topic. There's one more lecture video left, then I will be starting my past papers questions. Thank you dear. Enjoy your learning. Allah Hafiz.